This video is going to be an introduction to the use of vectors in 2 dimensions. To begin with, let's consider that we have a truck sitting at the point 3 meters in the x direction and 2 meters in the y direction from our chosen origin. We can draw a vector describing the position of this truck in our coordinate system, r vector, which always points from the origin to the location of that truck. And we can write r vector in terms of the x and y components of the truck's position using I hat and j hat notation. So imagine that I'm at the origin and I want to get to the truck. Well, I could get there by walking 3 meters in the x direction, and then by walking 2 meters in the y direction. This lower green arrow looks like the vector 3 meters I hat, and the vertical arrow here looks like the vector 2 meters j hat, which makes me think that I could write my r vector as 3 meters I hat plus 2 meters j hat. That is, I can write r vector in terms of how far I need to walk in the x direction plus how far I need to walk in the y direction. And we can do this for any vector. So for example, if I wanted to have some other vector, I'll just call it vector A. Vector A I could write as 1 meter I hat plus 2 meters j hat. Or I could have a vector that points in the negative direction. So for example, I could have a vector that points this way. Put some markers here. If I extend my coordinate system, then this yellow vector, I'll call it vector B, and I'll say that it points to the point negative 2 meters I hat plus 1 meter j hat. So I'm able to use this minus sign here to indicate that in order to get to my yellow point here, I need to walk to the left in the negative x direction for 2 meters, and I need to walk in the positive y direction for 1 meter here. So this is one way of writing vectors, and in general, it will be the most useful way for us to write vectors. We will write vectors in terms of their x and y components. I'll just add in x and y components for A here. Notice how I'm putting arrows on the components here as well. These are vectors in their own right, which when added together, lead me to the correct point, right? My green components here, if I follow them, I go 3 meters to the right and 2 meters up, I end up at my final destination. So this will be our most common way of writing vectors in 2 dimensions in terms of their x and y components, their I hat and j hat components. There is another way of describing vectors, and that is using their magnitude and direction explicitly. If you remember, we said that a vector, by definition, is a mathematical object that has both magnitude, that is a size or length, and a direction. This is our definition of a vector. Now, I don't explicitly see a magnitude or a direction in these vectors that I've written, right? This 3 meters I hat and 2 meters j hat, it tells me where I need to go, and it uniquely describes this red vector that points from the origin to my truck. But I don't know the length of that vector immediately from this. But luckily for us, all of that information is stored in there. It's just not immediately obvious. So the way that we can get this magnitude and direction information out is that we use our trig functions. So if I want to take my r hat vector, my r vector, I can write the magnitude of my r vector, which I write by putting absolute value signs on it. This is simply using Pythagorean theorem to find the length of my red arrow here. So that is going to be the square root of 3 meters squared plus 2 meters squared. And I actually should be a little more careful about writing this and give myself a little more space in writing this, because what needs to happen is that it is the square root of 3 meters squared plus 2 meters squared. The units meters get squared as well as the actual number. So my r vector magnitude is going to be 9 plus 4 square root, and I'm going to pull the meters outside there. So it would be the magnitude of my r vector is the square root of 13 meters. Now, if I want to know the direction, I can use trigonometry in order to find the angle that my r vector makes with the x direction. So, for example, I'm just going to redraw my r vector over here. And I'm going to draw just my x direction here. And I'm going to call this angle theta. So I know that my r vector has sides of 3 meters and 2 meters. And I know that the tangent of my angle theta must be 2 meters over 3 meters. So I can say that theta goes like the inverse tangent of 2 meters over 3 meters. Plugging this into the calculator gives an angle of theta equals 33.7 degrees. So if I wanted to write r vector, I essentially have two options. One option is to write it as an x and y component, or I could write r vector is the square root of 13 meters at an angle of 33.7 degrees counterclockwise from the positive x-axis. So this is just another way of writing my r vector. It explicitly tells you the magnitude at root 13 meters, and it explicitly tells you the direction in terms of an angle. And throughout the class, we will write vectors in both of these forms, as a magnitude and an angle, or in terms of two components. Whenever we're doing physics, however, it is almost always more useful to have the components than it is to have the magnitude and the angle. And in general, if you are given a vector as a magnitude and angle, you will want to use trigonometry in order to turn it into x and y components.